Hello, and welcome to this series on Dynamics 365 development. If you've been looking for a way to learn Dynamics 365 development that goes beyond basic tutorials, something that actually shows you how real projects are built from start to finish, then you're in the right place. Throughout these videos, we will build a complete end-to-end project from the ground up. This isn't just theory or disconnected examples, you'll see every step of a production-ready solution, just like you deliver to a real client. So, what exactly will we be building? The scope will cover extending tables and forms, implementing custom business logic using chain of command, creating automated batch jobs, building APIs for external system integration, setting up real-time alerts with business events in Azure, and visualizing the final data with a Power BI dashboard. These are the core skills that Dynamics 365 developers use every single day in the field. We will also incorporate professional practices like creating a technical design document and managing deployment through Azure DevOps. Because knowing how to code is only half the job, understanding how to document, version control, and deploy your work is what makes you job ready. Now, to make this practical and relatable, we'll base our project on a business scenario for a fictional client. Bluestone Industrial Components, or BIC. They are a B2B manufacturer whose sales team needs a more systematic way to identify and manage their high-value customers. To address this, we will be developing an automated customer tiering system. Here's what that means in simple terms. Imagine BIC has thousands of customers, but only a handful contribute the bulk of their revenue. The sales team wants to automatically categorize customers into tiers like silver, gold, or platinum based on criteria such as total purchase volume, account age, or payment history. Once a customer is tagged as platinum, for example, the system can trigger automated actions, send alerts to account managers, apply special pricing rules, or even notify external CRM systems in real time. That's the system we'll be building together. Applying these development techniques to a realistic business case provides a clear and practical way to understand how they function together in a real-world solution. You won't just learn isolated concepts, you'll see how everything connects. Before any code can be written, a solid development foundation must be established. This first video will focus exclusively on that setup process. We will configure the project portal in Lifecycle Services, set up a code repository in Azure DevOps, and deploy a local development machine. Getting this infrastructure right is a critical first step for any project, and it's what we'll tackle today. The process begins in Lifecycle Services, or LCS. This is where we'll set up the project hub that will coordinate our entire development effort, from environment management to deployment tracking. LCS is the central management portal for any Dynamics 365 project. Think of it as mission control. It's where you provision cloud environments, manage application updates, track project milestones, and connect to your DevOps repository. Microsoft uses LCS to ensure that all finance and operations implementations follow a structured, standardized approach, which is especially important when you're working with enterprise-scale systems. So we'll start by navigating to Lifecycle Services. Once we're logged in, you'll see the main dashboard. From here, we'll click on the plus icon to create a new project. This will open a new window on the right, prompting us to select a product. We'll click on Finance and Operations, since that's the application we're building our customization for. After that, you need to specify the purpose of this project. Here, we have three options: prospective, pre-sales, implementation, and on-premises implementation. Let me quickly explain what these mean. Prospective pre-sales is used when you're working with a prospect to help them understand business processes and evaluate subscription needs. Basically, it's a sandbox for demos and discovery. On-premises implementation is for customers who want to deploy Dynamics 365 locally on their own infrastructure rather than in the cloud. And implementation. This is the option designed for actual production projects that involve deploying a full-scale solution with dedicated environments. Since we're building the Bluestone Industrial Components customer tiering system as a real-world implementation scenario, implementation is the right choice for us. So we'll go ahead and select Implementation. Now, you might see a pop-up stating, Create an additional implementation project. This appears if you already have an existing implementation project in your account. As you can see, I already have one that I created earlier. However, in your case, you won't see this message if it's your first time creating a project. I'll go ahead and click Yes to proceed. Now we need to provide the project name and the description. For the project name, I'll use BIC Dynamics 365 Implementation. We're using the BIC prefix to clearly identify this as belonging to the Bluestone Industrial Components client, which helps keep things organized if you're managing multiple projects. For the description, I'll enter something meaningful that explains the scope of the work. Next, we can leave the project custom type set to none. You might be wondering what the other option is for. The only alternative here is Microsoft Dynamics 365 Human Resources Migration, which is specifically for projects that involve migrating from the standalone HR application into the unified finance and operations platform. Since we're not doing an HR migration, we'll keep this as none. Finally, we'll tick the checkbox to accept the terms of service and then click Create. Now we'll just wait for a few seconds while LCS provisions the project for us. Once it's done, the new project will appear on the main dashboard and we'll be ready to move forward with the next configuration step. So, let's click on the project to open it. Once we're inside the project, you'll notice the interface is organized into three main sections. Let me walk you through each one so you understand what you're looking at. First, on the left side, we have the Action Center. This is essentially your task dashboard for the project. It alerts you to anything that needs your attention. As you can see here, there are a few warnings showing that project milestones haven't been set, Azure DevOps hasn't been configured, and project onboarding isn't complete. Don't worry about these for now, we'll address them as we move through the setup process. Next, in the center, we have the methodology section. This visualizes the project lifecycle phases that Microsoft recommends for finance and operations implementations. You see 5 phases here: analysis, design and develop, test, deploy, and operate. These phases act as a structured roadmap with built-in checklists and milestones to guide you through a proper implementation. In a real enterprise project, following this methodology step by step is highly recommended. It ensures nothing critical gets missed and helps you track progress systematically. However, for our learning scenario, we're going to focus primarily on the technical setup and development work rather than completing every methodology task. You can click on any phase to drill down into the associated tasks if you want to explore what a full implementation checklist would look like. Finally, on the right side, we have the environments section. This is where you'll manage all the different environments for your project, things like sandbox environments for development and testing, or production environments for live deployments. You'll also see options for sandbox subscriptions, user license consumption, and service requests. Right now, the production environment shows configure because we haven't set it up yet, and there are some prerequisites that need to be met before we can deploy it. We'll be working with environments later in this video once we have the foundational setup complete. Now that we understand the layout of the project portal, we can move forward with the next configuration step. With the LCS project created, we'll now proceed to Azure DevOps. This is where we'll set up our source code repository and configure the version control system that will integrate directly with Lifecycle Services. Azure DevOps will host all the source code for the Bluestone solution and will be used to manage the development lifecycle, from tracking code changes and managing branches to automating builds and coordinating deployments back to our Dynamics 365 environments through LCS. So once we're inside the Azure DevOps portal, on the left pane we can click on the New Organization link. Azure DevOps will redirect us to a setup screen. This is a standard onboarding flow where we'll configure some basic details for our new organization. We click on Continue to proceed. Now, on this screen, we need to provide our organization a unique name. I'll enter BIC Dynamics 365, keeping it consistent with our project naming convention and making it easy to identify. Next, we'll select the hosting region for our projects. You'll notice the system has pre-selected a region based on your account location. It's generally a good idea to choose the region closest to where your team is located, as this can improve performance when accessing repositories and running builds. For most scenarios, the default selection works perfectly fine. Finally, we'll enter the captcha verification and then click on Continue. And that completes the organization setup. Azure DevOps will now create the organization for us, and in just a few moments, we'll be ready to configure it. Before creating the project, there are a couple of crucial organization settings we need to configure for compatibility with Dynamics 365 deployments. These settings ensure that LCS can properly integrate with Azure DevOps and automatically manage build pipelines and source control. So in the left pane at the bottom, we click on Organization Settings. Here, I'll scroll down and then click on Repositories. This will open all the settings associated with repository management. You'll notice that by default, the option Disable Creation of TFVC repositories is enabled. We need to disable this toggle. Now, you might be wondering why we're using TFVC, Team Foundation Version Control, when the industry has largely moved to Git for source control. The reason is that Dynamics 365's integration with Lifecycle Services was originally built around TFVC, and many of the automated deployment processes, including build server provisioning and environment sync, still rely on it. While Microsoft has been transitioning Azure DevOps toward Git-based workflows, the LCS integration for finance and operations hasn't fully made that shift yet. So for now, we need TFVC enabled to ensure everything works smoothly. Next, under the pipeline section, we'll click on Settings. Here, under the General section, you'll see two options related to classic pipelines. We need to ensure that the toggles for Disable Creation of Classic Build Pipelines and Disable Creation of Classic Release Pipelines are both set to off. Let me explain why this matters. Azure DevOps has two types of pipeline systems: the newer YAML-based pipelines, which use code to define build and release processes, and the older classic pipelines, which use a graphical GUI-based editor. Microsoft now encourages YAML pipelines for new projects, so by default, classic pipelines are disabled. However, when LCS provisions build environments and sets up automated deployments for Dynamics 365, it still automatically sets up classic pipelines, not YAML ones. If we leave these toggles enabled, LCS won't be able to create those pipelines on our behalf. So we need to turn these restrictions off to allow LCS to function properly. With these settings configured, our Azure DevOps organization is now properly set up for Dynamics 365 development. We can now move forward with creating the actual project. For the project name, we'll use BIC Dynamics 365 implementation, staying consistent with our naming convention. Then we'll provide a brief description. I'll enter the same description we used in LCS. Next, we need to expand the Advanced Settings section. Here, under Version Control, you can see that by default it's selected as Git. We need to change this to Team Foundation Version Control, which is what we enabled in the organization settings earlier. This ensures compatibility with the LCS integration. We'll leave the work item process set to basic. The work item process setting controls how you track and manage work in your project. The basic process offers a straightforward way to track tasks, bugs, and issues. Ideal if you just want a simple to-do list and bug tracker without extra layers. In contrast, Agile and Scrum processes add more structure. They include features like user stories, sprints, backlogs, and more detailed workflow states, which are helpful for teams following formal project management methodologies. For our purposes, since we're mainly focused on development and not running a full Agile or Scrum process, the basic template keeps things simple and easy to manage. After that, we'll click on Create Project. Azure DevOps will now provision the project for us, and in a moment, we'll have our new workspace ready to go. Once the project is created, we're taken to the project overview page. Let me walk you through the main sections you'll be working with throughout this series. On the left side, you'll see the navigation menu with several key areas. Overview provides a dashboard summary of your project activity and description. Boards is where you'd manage work items like tasks, bugs, and sprints if you're following agile methodologies. Repos is the repository section where all your source code and files are stored. This is what will sync with LCS and contain our Dynamics 365 customizations. Pipelines is where build and release automation happens. You'll define processes here that compile your code, run tests, and deploy to environments. Test plans allows you to organize manual and automated testing efforts. And artifacts is used to manage packages and dependencies for your projects. For our implementation, the two most critical sections will be repos and pipelines, since those directly integrate with Dynamics 365 deployments through LCS. So let's hover over repos in the left pane and then click on Files. This will take us into the repository file browser. Right now, it's empty, but this is where all the code and metadata files for our Dynamics 365 customizations will eventually be stored once we sync our development environment. Next, let's check out pipelines. In the left pane, we click on Pipelines. Right now, as you can see, it's empty and prompting us to create a pipeline. Later in this setup process, when we connect LCS to this Azure DevOps project, LCS will automatically create build pipelines here that compile our Dynamics 365 code into deployable packages. So for now, we'll leave this empty, but just know that this is where those automated processes will live once we complete the integration. With our Azure DevOps project now created and configured, the next critical step is to establish the connection between LCS and Azure DevOps. This integration is what allows LCS to access our source code, trigger automated builds, and deploy customizations to our environments. To do this, let's return to Lifecycle Services. Here, we'll click on the BIC Dynamics 365 implementation project that we just created. Once it opens, you will see a menu icon at the top. Click on it, and from the drop-down menu, select Project Onboarding. This opens the Project Onboarding wizard. The welcome screen gives a brief overview of what we'll be configuring. We can simply click Next to proceed. Now we are on the project overview step. You'll notice the project name is already pre-filled from what we entered earlier. Let's add a description here as well. I'll enter the same description we've been using. Next, we need to specify the implementation partner. We'll select Partner Not Yet Identified. In a real-world scenario, this field would identify the consulting or implementation partner responsible for delivering the project. Since this is a demo project for learning purposes, we don't have a formal partner relationship, so this option is appropriate. After that, we fill in a few additional fields. For implementation team country, I'll select India. This should reflect where your team is primarily located. For legacy system, you'll see a variety of legacy ERP systems like AX 2012, AX 2009, Dynamics GP, Infor, and several others. This field is used to indicate what system you're migrating from, which helps LCS track the project type and provide relevant guidance. Since we're building a fresh implementation rather than migrating from a specific legacy ERP, we'll select Other from this list. And for preferred Azure region, I'll select Central India. Choose the region closest to your location for optimal performance when deploying cloud environments. You will also see a field for future user licenses with categories for full users, team, activity, and device. This is where you estimate how many Dynamics 365 licenses you'll need once the system goes live. These numbers help Microsoft understand the scale of your deployment and can influence environment sizing recommendations. For our demo project, I'll just enter zeros across all categories since we're not planning an actual production rollout with real users. In a real implementation, you'd work with your licensing team or Microsoft representative to estimate how many users will need full access, how many will be occasional team members, and so on. Once these fields are filled in, we'll click Next. Now we're on the project scope section. Most of the fields here are optional, but if we scroll down, we'll see a few that are mandatory and need to be addressed. Under Dynamics 365 Apps for customer engagement and field service, we'll select No. These applications are part of the Dynamics 365 CRM suite, which focuses on customer relationship management. Things like managing sales pipelines, tracking customer interactions, handling marketing campaigns, and coordinating field service operations. If you were building a solution that needed both capabilities, for example, if BIC wanted to track sales opportunities and also manage their back office operations, you'd select Yes here. But for our customer tiering system, we only need the F&O platform. Under Power Platform, we'll select Yes for Power Automate, Power BI, and Power Apps. We're enabling these because our project will use Power BI to build reporting dashboards, and we'll also be working with business events later on, which can integrate with Power Automate for real-time automation. Even though we're not actively using Power Apps in this series, it's a good practice to enable the full Power Platform stack for future extensibility. Once that's complete, we'll click Next. Here, we need to define our team. You will see a message at the top stating that we require at least 2 users with active email addresses designated as primary contacts for Fast Track. Fast Track is Microsoft's customer success program that offers guidance and support throughout your implementation. Therefore, they need a way to reach the appropriate people on your team at various stages of the project. Right now, my name is already added with the role of project manager. To make this user a primary contact, we'll click on the edit icon. In the panel that opens on the right, we'll toggle primary contact for Fast Track from No to Yes and then click Save. That's one primary contact configured. Now, we need to add at least one more user. We'll click on the plus icon to invite a new user. In the invite panel, I'll enter a username and provide an Outlook email address. For the project security role, I'll select Environment Manager. This role has access to all tools in Lifecycle Services and can manage cloud-hosted environments. And finally, we'll enable the primary contact for Fast Track toggle to Yes. Once that's done, we'll click the Invite button. Now, in a real-world scenario, you'd be adding actual team members with their legitimate email addresses and assigning roles based on their responsibilities. For this demo, I'm just using sample data to satisfy the requirement. But when you're doing this for an actual project, make sure you're inviting the right stakeholders, developers, functional consultants, project managers, and so on. Now that our team is defined, we can move to the next step, where we will define the milestone dates. Here, we'll click on the Edit button. In the pane that opens on the right, you'll see 4 standard project milestones: analysis, design, test, and go live. These are the core phases of a Dynamics 365 implementation and align with Microsoft's recommended methodology. Let me briefly explain what each phase represents in a real project. The analysis phase is when you gather requirements, document business processes, and define the scope of the solution. The design phase is where you create the technical and functional design, plan customizations, and finalize the architecture. The test phase involves user acceptance testing, performance testing, and validating that the solution meets all requirements. And finally, go live is when you deploy to production and hand the system over to end users. In a real implementation, these dates are critical. They dictate when environments are provisioned, when Microsoft Fast Track provides support, and when certain features become available in LCS. For now, we'll just enter some sample dates for each milestone to complete the onboarding process. Once we've entered the dates, we'll click Save. Finally, we'll click Next to proceed to the next step. In this step, we need to establish the integration between LCS and our Azure DevOps repository. To do this, we must generate a personal access token from Azure DevOps. Let's switch back to Azure DevOps. At the top right corner, you'll see a user settings icon. We'll click on it and from the drop-down menu, select Personal Access Tokens. Right now, we don't have any tokens created, so we'll click on New Token. In the dialog that opens, let's provide a name for this token. I'll call it LCS Authorization. We can leave the organization and expiration date at their default values, typically 30 days, though in a production environment, you'd want to set an appropriate expiration based on your security policies. Now, under scopes, we need to define what level of access this token will have. You will see two options, full access and custom defined. I will select full access. For this integration to work properly, LCS needs broad permissions. It will be setting up build pipelines, accessing source code repositories, managing work items, and triggering builds on our behalf. In a production scenario, you'd want to review your organization's security policies. But for a development and learning environment like ours, full access simplifies the setup and avoids troubleshooting permission errors later. Once that's set, we'll click Create. A success window will appear with our newly generated token. This is important. You'll see a warning that says you need to copy this token now because Azure DevOps doesn't store it and you won't be able to see it again. So let's click the copy icon to save this token to our clipboard. Great. Now let's switch back to LCS. In the personal access token field, we'll paste the token we just copied. Next, we need to provide the Azure DevOps site URL. The format for this is your organization name followed by visualstudio.com. So in my case, it's bicdynamics365.visualstudio.com. After that, we'll click Connect LCS with Azure DevOps. LCS will now test the connection using the token we provided. Perfect. The connection succeeded. Now we need to configure the Azure DevOps integration. In this screen, we need to select the Azure DevOps project we want to link with this LCS project. Right now, we only have one project, BIC Dynamics 365 implementation, so we'll select that from the dropdown. After that, we'll scroll down to the bottom. You'll see an option that says Set the work item types above. We need to toggle this to Yes. Let me explain what this setting does. Work item type mapping is how LCS synchronizes project management tasks between Lifecycle Services and Azure DevOps. When you enable this, LCS will map its built-in methodology phases and tasks to corresponding work item types in Azure DevOps. For example, business process requirements might map to epic, functional specifications might map to task, and issues might map to bug. This integration allows you to track implementation progress in Azure DevOps while LCS monitors overall project health. Finally, we click Next to proceed. Now, this section just contains some information about the Fast Track team and their role in supporting Dynamics customers. We'll simply click Next to continue. On the following screen, you'll see some details and helpful resources about next steps in the project onboarding process. It's worth reviewing if you're interested, but for now, we'll scroll down and click Next to move forward. Finally, we'll click on Complete Onboarding. A confirmation pop-up will appear. We'll click Yes to finish the onboarding process. Perfect. Now, if you look on the right-hand side of the LCS project page, you'll see that the configure option is now enabled for the standard acceptance test environment. This is a default sandbox environment that LCS provisions for every implementation project. Now, we need to link our Azure subscription to LCS before we proceed further with the project setup. While the standard acceptance test environment we see here is actually Microsoft managed and doesn't run in our Azure subscription, we'll need this Azure connection later in the series when we deploy cloud-hosted VMs. Specifically, the development virtual machine and build server that will host our customization work. Those resources will run in your Azure subscription and consume your credits. So we're setting up this link now as part of the foundational configuration, even though it's not required for the immediate deployment we're about to do. To do this, we first need to configure some permissions in the Azure portal. Let's switch over to Azure. Here, under Resources, you can see the Azure subscription that we have. We'll click on it to open the subscription details. Next, in the left pane, we'll click on Access Control. This is where we manage who or what has permission to create and manage resources within this subscription. Here, we'll click on Add and then select Add Role Assignment. Now, you'll see two tabs at the top, Job Function Roles and Privileged Administrator Roles. Let me quickly explain the difference. Job function roles are designed for everyday tasks and follow the principle of least privilege. They give just enough access to perform specific functions like managing virtual machines or reading storage accounts. Privileged administrator roles, on the other hand, provide broader access to manage resources across the subscription. Since we need to give LCS the ability to create VMs, configure networking, manage storage, and perform various deployment tasks, we need a privileged role. So, we'll click on Privileged Administrator Roles. From the list, we'll select Contributor. The contributor role allows full management of Azure resources, creating, modifying, and deleting resources, but doesn't allow assigning permissions to others. This is exactly what LCS needs to deploy and manage our development environments. After selecting Contributor, we'll click Next. Now, under Members, we need to specify who we're granting this access to. We'll click on Select Members. In the search box that appears, we'll type Dynamics Deployment Services and select it. This is a Microsoft Managed Service Principal, essentially an identity that represents Lifecycle Services within Azure. By adding it as a contributor, we're authorizing LCS to act on our behalf and deploy resources into our subscription. Once selected, we'll click Select. Then, we'll click Next. On this final screen, we can review all our selections to make sure everything is correct. Finally, we'll click Review and Assign. Azure will now grant the contributor role to the Dynamics Deployment Services principal. Great! The role has been successfully added. To verify this, we can click on the Role Assignments tab. If we scroll down under the contributor role, we can see Dynamics Deployment Services listed there, confirming that the service principal now has the necessary permissions. Perfect. We're all set here, so let's head back to Lifecycle Services to continue with the environment configuration. Now, back in LCS, we'll open the hamburger menu at the top and click on Project Settings. From the left-hand menu, we'll select Azure Connectors. This is where we configure the connection between LCS and our Azure subscription. The first thing we need to do is authorize LCS to access our Azure resources. We'll click on the Authorize link under the Organization List section. This takes us to the Grant Admin Consent page. Here, we'll click the Authorize link again and we'll be prompted to sign in with our work account. Once we proceed with the sign-in, a permissions request dialog will appear, asking us to grant specific permissions. Essentially, this is granting Dynamics Deployment Services the ability to act on behalf of your organization in Azure. Specifically, to access the Azure Resource Manager, read your user profile, and manage resources within your subscription. These permissions are necessary for LCS to deploy VMs, configure networking, and manage cloud-hosted environments automatically. Without this authorization, LCS wouldn't be able to provision infrastructure in your Azure subscription. We'll click Accept to grant these permissions. Once the authorization completes, we'll get back to the Azure Connectors page in LCS. Next, we need to add a connector that links to our specific Azure subscription. Under the Azure Connectors section, we'll click the Add button. A Microsoft Azure Setup pane will open on the right. Under Name, we can provide any descriptive name to identify this connector. Under Azure Subscription ID, we need to paste the subscription ID from our Azure account. Once we've entered the name and subscription ID, we'll click Next. Here, LCS is verifying the contributor role we assigned earlier in Azure. You can see Dynamics Deployment Services listed with a green check mark, confirming that LCS has the necessary permissions to deploy resources. We'll click Next to continue. The next screen displays some information about subscription authorization and ownership verification. This is mostly informational, so we can simply click Next. Now we need to select the Azure region where our cloud-hosted resources will be deployed. This is important. When LCS provisions virtual machines, like the development VM or build server, they'll be physically located in the region you select here. Choosing a region close to your team's location ensures better performance and lower latency when accessing those machines. I'll select Central India since that's nearest to me, but you should choose whatever region is closest to you. If you're in the US, choose a US region. If you're in Europe, choose a European region, and so on. Finally, we'll click Connect. Perfect. The connector is now listed under Azure Connectors, confirming that our LCS project is successfully linked to our Azure subscription. We're all set to deploy cloud-hosted environments whenever we need them. With the cloud infrastructure configured and interconnected, we can now deploy our first environment. On the project dashboard, under the Environment section, we'll click the Configure button for the standard acceptance test environment. The first screen prompts us to choose the application and platform version. By default, it shows version 44. However, I'll be changing this to version 43. The reason is that later in this series, we'll be downloading and deploying a local development VM from the shared asset library. The VHD file I'll be using is based on 43 version, so keeping everything aligned prevents version mismatch issues down the line. Once we've selected the version, we'll click Next. This opens the deployment settings window. On the left, you'll see a series of configuration steps we need to complete. Let's start with the General tab. Under Environment Name, we will enter BIC Sandbox. This will be embedded within the environment's domain name. Under Geography, I'll select Central India. Again, choose the region closest to you for optimal performance. After that, we'll click Next. Now we're on the Change Selected Topology step. The topology is already set to the appropriate sandbox configuration, so we'll leave it as is and click Next. Next up is Customize SQL datasets. Here, the AX database is set to demo by default, which means the environment will be pre-populated with demo data, sample customers, products, transactions, and so on. This is useful for learning and testing as it gives you realistic data to work with right out of the box. We'll keep it as demo and click Next. The next step is Customize Solution Assets. This is where you'd select a business process modeler library if you had one configured. A BPM library is a documentation tool where you outline how a business operates and map those processes to Dynamics 365 features. Since we're building a learning project without a real client, we'll leave this blank and click Next. Now we're on Power Platform integration. Since we're not integrating with Power Platform at this stage, we'll leave it set to No and click Next. Next is Environment Notifications. This is where you add email addresses for people who should receive notifications about this environment. Things like deployment completion, scheduled maintenance, unplanned downtime, or when updates are applied. I'll add a couple of email addresses here so that relevant stakeholders stay informed. In a real project, you'd add your project manager, lead developer, and any other key team members. After entering the email addresses, we'll click Next. Now we need to assign an environment administrator. This is the user who will have admin level access to the deployed environment and can manage security, configurations, and user access. Since I'm the only user in this project, I'll select myself. In a real implementation, you typically assign this role to a lead consultant or system administrator who will be responsible for managing the environment. Once that's selected, we'll click Next. We're now on the summary step. It's a good idea to review everything here to make sure nothing was missed or misconfigured. Once we've verified everything, we'll click Next. The final step is customer sign-off. This is a formal acknowledgement that you've reviewed the deployment settings and accept the terms. We'll type our name in the text box to confirm and then click Save. Finally, we'll click Deploy. After clicking Deploy, you'll notice the environment status changes to Deploying. We can click on the full details link to monitor the progress. The deployment process typically takes 1 to 2 hours to complete, so we'll need to be patient while LCS provisions the environment. Great, the deployment has finished successfully. Now we can see the environment status shows deployed and the login button is available. We'll click on login to access the environment. This opens the Dynamics 365 Finance and Operations application, fully hosted in the cloud and accessible through a web browser. As you can see, our cloud-based Sandbox environment is now completely operational and ready to use. While this cloud environment is necessary and will be useful for certain scenarios, like testing integrations, accessing business events that require cloud connectivity, or sharing environments with team members, day-to-day development work is typically more efficient on a local machine. A local development VM gives you faster performance, the ability to work offline, direct access to code and databases, and better control over the development environment. That's why we'll now set up a local virtual machine for our actual customization work. The next step is to download the virtual hard disk, or VHD, from the shared asset library. A VHD is essentially a complete, pre-configured computer packaged as a single file. It already has Windows installed, Visual Studio setup, and Dynamics 365 fully configured. So you don't have to install anything manually. You just load it into virtualization software like Hyper-V, and it runs like a separate computer on your machine. Let's navigate back to the Lifecycle Services homepage. From here, we'll click on the Shared Asset Library tile. Once the Shared Asset Library opens, we need to filter by asset type. On the left side, we'll click on Downloadable VHD. Here, you'll see a list of available VHD files for different versions of Dynamics 365. The VHD we need is split into 4 separate files, 1 executable file and 3 compressed archive paths. This is done because the full VHD is very large, so Microsoft splits it for easier downloading and handling. We'll download all the 4 parts that matches our Sandbox environment. Depending on your internet speed, this could take some time since the total size is quite large. Once the download completes, let's navigate to the Downloads folder. Here, you'll see all 4 files. One is an executable file and the other 3 are compressed archive files. The executable file is special. It's designed to automatically merge all 4 parts and extract them into a single usable VHD file. We'll double-click on the executable file to launch the extraction wizard. A license agreement screen appears. We'll click Accept to agree to the Microsoft software license terms and proceed. Now, we need to specify where the VHD will be extracted. This file is around 133 GB, so make sure you have enough space on the drive you choose. I'll navigate to my D drive and create a new folder called Hyper-V to keep things organized. Back in the extraction wizard, we'll paste the destination path. In my case, that's the Hyper-V folder we just created on the D drive. Once the path is set, we'll click Extract. The extraction process will now begin. This typically takes between 5 to 10 minutes, depending on your system's disk speed. Perfect. If we go back to the Hyper-V folder, we can now see a single VHD file, approximately 133 GB in size. This is our complete Dynamics 365 Finance and Operations development environment, ready to be loaded into Hyper-V and used for local development. Now that we have the VHD extracted, we need Hyper-V Manager to run it. Hyper-V is Microsoft's virtualization platform that comes built into Windows Pro, Enterprise, and Education editions. However, it's often not enabled by default, so we'll need to turn it on first. In the Start menu, we'll type Windows Features and a quick link labeled Turn Windows Features On or Off will appear. We'll click on it to open the Windows Features dialog. In the list that appears, we need to make sure that Hyper-V is checked. If it's not, simply tick the checkbox next to Hyper-V and click OK. Windows will then install the feature, and you'll likely need to restart your computer for the changes to take effect. Once Hyper-V is enabled, we can launch it. In the Start menu search bar, type Hyper-V and open Hyper-V Manager from the results. Now we'll create a new virtual machine. In Hyper-V Manager, on the left side, you'll see your computer name listed. We'll right-click on it, hover over New, and then select Virtual Machine from the sub-menu. The new virtual machine wizard will open. The first screen is just introductory information, so we'll click Next to proceed. Now we need to provide a name for our virtual machine. I'll type BIC Dynamics 365 VHD to keep the naming consistent with our project. Once that's entered, we'll click Next. Next, we're prompted to specify the generation of the virtual machine. By default, Generation 2 is selected, but we need to change this to Generation 1. The reason is that the VHD we downloaded from Microsoft is in Generation 1 format. Generation 1 VMs use the older BIOS-based boot system and are compatible with legacy virtual hard disks, while Generation 2 uses UEFI and requires newer VHDX formats. Since our downloaded VHD is a Generation 1 disk, we need to match it. Once the generation is selected, we will click Next. Now, we need to assign memory to the virtual machine. Dynamics 365 development environments are resource-intensive. Microsoft officially recommends a minimum of 16 GB of RAM for optimal performance. For this setup, I'll allocate 12 GBs, but if your machine has more RAM available, allocating 16 GB or more will give you a noticeably better development experience. Once you've entered the memory amount, click Next. On the Configure Networking screen, we need to choose a virtual network adapter. We'll select Default Switch from the drop-down. The default switch is a built-in virtual network in Hyper-V that provides NAT-based internet connectivity, allowing the VM to access the internet through your host machine's connection. This is perfect for development scenarios. We'll click Next to continue. Now, we're at the Connect Virtual Hard Disk step. This is the important part. We need to attach the VHD file we extracted earlier. We'll select the second option, Use an existing virtual hard disk. Next, we'll click the Browse button and navigate to the location where we extracted the VHD. In my case, that's the Hyper-V folder on the D drive. We'll select the VHD file. Once the VHD path is populated, we'll click Next. We are now on the summary page. This shows all the configuration choices we made: the VM name, generation, memory, network adapter, and the attached VHD. We'll review everything to make sure it's correct and then click Finish. Perfect. The virtual machine has been created. If we look at the virtual machines list in Hyper-V Manager, we can now see BIC Dynamics 365 VHD listed with a state of off, which means it's ready to be started whenever we need it. Now let's start the virtual machine. We'll right-click on VHD and select Start. The VM will begin booting up. Once it's running, we'll right-click on it again and select Connect to open the virtual machine window. Now, we need to enter the login password. The default password for Dynamics 365 VHDs is password1. We'll type it in and press Enter. Perfect. We're now logged into our local development environment. Before we can access the Finance and Operations application, we need to configure authentication by registering an app in Azure. The reason we do this is that Dynamics 365 uses Azure Active Directory for authentication. When you try to log into the local VM's Dynamics 365 instance, it needs to verify your identity against Azure AD. By creating an app registration, we're essentially telling Azure this local application is authorized to authenticate users on behalf of our organization. Without this registration, the local environment wouldn't know how to validate your login credentials. So, let's open the Azure portal. In the top search bar, we'll type App Registration and you'll see it appear under Services. We'll click on App Registrations. Here, we'll click on New Registration. Under Name, we'll provide a descriptive name. I'll enter BIC Dynamics 365 VHD so it's clear what this registration is for. Next, under Redirect URI, we need to enter the URL of our local VM's Dynamics 365 instance. Make sure the platform dropdown is set to Web. This is the address where Azure will redirect authentication responses after successfully verifying your identity. Once that's filled in, we'll click Register. Great. The app registration is now complete. On the overview screen, you'll see important information including the application ID. This is the unique identifier that links our local VM to this Azure app registration. We'll need to copy this ID. Now, back in our virtual machine, we need to run a PowerShell script to generate a self-signed certificate. On the desktop, you'll see a shortcut called Generate Self-Signed Certificate PowerShell Script. We'll double-click it to launch the script. The script will prompt us to enter the application ID. We'll paste the client ID we just copied from Azure and press Enter. Next, it asks whether we have an existing certificate for this application. Since this is a fresh setup, retype N for no and press Enter. The script will now execute. It's generating a self-signed certificate that allows the local Dynamics 365 environment to securely communicate with Azure AD. This process takes a few minutes. Once it's complete, you'll see a message stating that new self-signed certificates have been generated. The final step is to run the admin user provisioning tool. This tool assigns admin privileges to your Azure account within the local Dynamics 365 environment. Let's navigate to the C drive, then go to Packages local directory, and then open the bin folder. In this folder, scroll down until you find Admin User Provisioning. It's an application file. We'll right-click on it and select Run as Administrator. A window will pop up asking for our email address. We'll enter the same work email that's associated with our Azure account and click Submit. What just happened is that your email account has been registered as a system administrator in the local Dynamics 365 database, which is why you'll be able to log in with full admin permissions. With that complete, our local environment is fully configured and ready to use. Now let's access the Finance and Operations application through the web browser. First, we need to find the correct URL. We'll open IIS Manager. IIS stands for Internet Information Services, and it's the web server that hosts the Dynamics 365 application on this VM. Think of IIS as the engine that serves the application pages when you access them through a browser. In the Start menu, type IIS and open Internet Information Services Manager. On the left panel, we'll expand the server node. It's listed with your VM's name. Under that, we'll expand sites and then click on AOS service. On the right side, under Browse Website, you'll see a link. This is the URL where the Dynamics 365 application is hosted locally. You'll notice this is the same URL we entered earlier as the redirect URI in our Azure app registration. That's how Azure knows where to send authentication responses. We'll click on the link to open it in the default browser. The application will start loading. This might take a minute the first time as various services initialize. And there it is. Finance and Operations is now running successfully in our local development environment. If you look at the top right corner, you can see our email address logged in as the admin user. This confirms that the admin user provisioning tool worked correctly, and we now have full administrative access to customize and develop on this system. Let's quickly recap what we accomplished in this video. We set up Lifecycle Services, configured Azure DevOps for source control, deployed a cloud sandbox environment, and installed a local development VM with Hyper-V. We now have both a cloud environment for testing and a powerful local machine for building our Dynamics 365 customizations. Thank you for following along. We'll see you in the next session.